Should I go
Okay.
live or not?
Let me stop sharing the whole screen. Okay, finally, I guess that's
Yes,
us
yes.
going live. It took us just 4 minutes to find go live button to try to try three different approaches. Yeah, but that's the first time we are using Riverside. At least I'm using Riverside as a host. So happy to see you all here, and thank you, Boris, for coming to mock me and to embarrass me in front of the whole internet. I'm looking forward to it. And everyone present already knows what this will be about, but let me just repeat myself a little. So, uh, I'm a machine learning engineer, like officially, yeah, I'm a manager. I have some people who report to me, but essentially, I work more like a staff engineer in my company. But I guess you can put me on any level below staff, and it would also be fine. And we me and Boris, we are friends for like many years, but you probably know Boris much better than you know me. And I guess he will introduce himself. So yeah, Boris, go on.
Right. Well, this is what it takes to friends to have a call nowadays. You have to schedule a podcast.
Yeah.
um, my name is Boris. I'm the admin of this Russian language Telegram channel about machine learning, a staff engineer of machine learning at eBay currently. And yeah, me and Ivan, we know each other for some time, and I'm like really excited. I know this is cliche, but really excited about this thing because I think it's a really cool video to make, a really cool stream to make, and it should be fun, I think.
Yep. So without further ado, again, our idea, I really don't know what Boris will be asking me about. My idea is like, for now, I'm just asking my friends to interview me because I tried to do it myself and it was very dull. And when there is a real person on the other side, it's much better. And also, it's like higher stakes and people can ask what they want to ask. So it's like these interviews are covering the whole breadth, possible breadth of like whatever people are asking in machine learning system design. It doesn't have to be like fun like interviews. It doesn't have to be any specific thing. It's just what they want. So, Boris, what do you want today? Let me start sharing Excalibur and we can take it from there. So I will be sharing this tab, share. I think, yeah, I think it should be seen now.
Yeah, I can see it. I think you can draw. I don't think. Yeah, I don't think I
Yep.
even need access to that. All right. Well, the way I usually do that, and as we agreed, I will try to make this the way I basically perform real interviews, maybe
Mhm.
um, slightly less seriously, but still. And the way I usually do that is first, let's agree on how this is gonna go. So I'm gonna present you with a problem, which is a high-level kind
Mhm.
of machine learning system design style problem, and the
Mhm.
goal is to for us to explore the problem together as if we were already working on it, already working together, and we need to solve something for the company or rather outline a solution. Of course, we'll not be coding any stuff right, and launching it and
Okay.
all that right now. Yeah, the important part is that I mostly expect you to think out loud, and you should not be looking for any like gotchas. I'm not looking for any specific right answers. It's a very open-ended problem, so I'm really interested to hear your thoughts and also your questions. Like
Mhm.
in some interviewers they don't consider it okay to ask questions. So I want to explicitly state that it is okay, especially if you need to clarify something.
Okay.
Well, basically that's it. Is that clear? Do you have any questions about the
Yep.
format?
That's clear. No
Okay.
questions for now. Let's do it.
All right. So here's the problem. Imagine we are classified slash e-commerce website that will go unnamed and completely unknown to all people watching. Um, So we have high loads of a lot of items people sell in both like two modes, peer-to-peer kind of people selling, just regular people selling to another, and shops selling to people. And when you
Mhm.
have such high loads and you're present on many countries, many jurisdictions, and so on, eventually you encounter risk problems. So this is what the problem, the task is going to be about,
Mhm.
and the problem we're trying to solve. The problem is called product safety. So there are
Mhm.
dangerous things, and we have specific policies. So imagine we have a website, we have the policies written, legal teams working on that, and so on things that should not be sold on the website. There are many things that should not be sold, but product safety is like about the most important ones of those things that are like really dangerous. At the same time, yeah, let's keep it simple for now. So let's say we're looking for universally dangerous things. For example, it could be dangerous chemicals. Some chemicals are prohibited from sale everywhere, and our website has to enforce that as well. And another example would be more kind of specific. There are certain breastfeeding devices that are dangerous for, well, like baby feeding devices that are dangerous for the babies. So this is an instance where a specific kind of product was kind of universally recalled and is prohibited from sale basically everywhere. But it's not like something like a chemical which is the same everywhere. It's
Mhm.
a specific product. There can be, and this is one aspect of the problem, so there can be many such policies, and this list it keeps getting updated, of course. So new stuff is discovered to be dangerous while also being sold. But for now, let's assume there is a specific list of things, of kind of issues. Like one issue could be dangerous chemicals, and
Mhm.
a list of specific chemicals that should not be sold. And the problem is that some people still want to sell them for one of two reasons. It could be malicious. So it could be that people are trying to make money this way while knowing that um,
Mhm.
these things are prohibited, so against the rules. But more often, it's not malicious. People just don't know. You just have this thing, you want to sell it.
Mhm.
And you're like, of course, people do not read all the rules of every website they use.
Mhm.
So the task is that to design a system that will allow to detect things that are currently being sold on the marketplace and then report them to another system that will handle the actions taken upon it. So usually the action will be like hiding the item, removing the item, contacting the seller, informing them of the problem, and so on. But for you, the issue is that these items have to be found. The task is challenging for the reasons of scale. So clearly we have, let's assume we have tens of thousands of new items appearing on the website every day. Physically cannot be sorted through by people. So a system should be designed given that for a specific policy it will be reliably finding mm, the items that, well, are against this specific policy. We could formulate it this way.
Mhm.
I think
Okay.
that's it with the introduction. Yeah. So, do you have any questions?
Yep. I just want to specify a few things. Like one thing that came to mind is we are just reporting things to a different system, but you mentioned that we should like find items that are already being sold. But it sounds like we should also, since there are a few people who just don't know, then there should probably be a different step in the like introduction of the product to the system. Like if you want to start selling your item, maybe you're a good-natured person who just doesn't know things. So we just show that, okay, your item is probably this one. Do you really want to sell it because it's prohibited according to this policy, whatever? And then it just doesn't even appear on the site, and then people can do their own moderation as long as they're not malicious actors. So but it's not like reporting to a different system. It's earlier
Yeah, yeah.
step in the process. So should we consider something like this, or do I just want to focus on items that are
It's
already being
actually
sold?
It's actually a great like suggestion of yours because it is a real system. Like on all such in all such systems, there are two approaches to this. One is like
Hmm.
uh, preventing stuff from getting even sold, and the other one is finding stuff already being sold. And for this one, they are slightly different problems. Let's focus
Hmm.
on the like how do you say it, reactive,
Hmm.
when stuff has already been sold, but both are absolutely valid.
Hmm. Okay. We will be focusing on reactive part. Okay, then basically you're saying that we are adding 10K items per day, which is a lot, but essentially it means that we are adding just a few items per minute, and it doesn't sound like that of a big scale. So
It's true, like let's say we're not a huge website yet, but keep in mind that we have big plans. We will be
okay, big
expanding to
plans.
and so on.
Uh,
Yeah, but for now,
Sounds
yeah,
good.
let's stick with this scale.
Also, another thing that is important here, like let's say we have an item posted, and then can we edit this item? So, for example, can I
Yes.
post something simple, but then it's getting updated, and then people are substituting like normal stuff with malicious stuff just
Yes, this
to
happens.
okay, so makes sense. Then basically act on uh, create or update. So our system basically will be acting on these two things. Um, I'm thinking now if I'm missing anything. Like, for example, do we need any additional checks? Like, for example, let's say we have a customer who wants to buy an item, and like prior to them buying the item, we maybe there is some dialogue that where we can see that um, the item is actually malicious. I probably won't go in this direction, but maybe what I'm trying to say is maybe at the point when we upgrade or update an item, we don't have all information and we get more
Yeah.
information as the item stays on the site. But I will keep it out of scope for now. Is it fine?
Yeah, it's fine, and that makes me think I actually forgot an important part. So
Mm-hmm,
here we are trying to mitigate two risks.
mm-hmm,
One risk is that yeah, a person buys an item, gets hurt, and then we suffer reputational risks. Overall, bad for everyone.
mm-hmm,
Uh, yeah, just bad. But another risk is that each country has regulators that will
mm-hmm,
sometimes very randomly and in very small volumes check for stuff. Especially, usually it happens when something happens. So if somebody gets hurt or whatever, then usually a regulator will after some time come and check, is this website really selling, I don't know, something prohibited
mm-hmm,
of this kind. And here the company gets lawsuits. So the
mm-hmm,
two risks we have are essentially legal and people getting hurt. And we
mm-hmm,
have to consider both. And for the second one, for the legal, for a regulator, they will not be buying. So if you only act on purchase, then it's too late. Yeah.
Yeah, I get it. What I was saying, I don't want to act on purchase. I want to get more information during the discussions that sellers can have with their customers. And maybe we will get more information to classify the item correctly. But I guess I will just leave it out of scope and I will focus like on all the information that is present when the item is created or updated, which is kind of the same information, it's
Yes,
just
I
two
think.
different triggers.
Yeah, I think that's the point at which you should already be making some decision.
Okay, sounds good. And then I get the risks. So I think I'm trying to see if those risks translate into different um, approaches to this problem. But for now, I see it as like um, for us, the costs of item being present, then it shouldn't be. So let's call it like if we are identifying bad items, then it's like false negative. So false negatives are the worst thing for us. False
Yeah,
positive, like false negatives are costly. Negatives. more costly than false positives. False positives are, to be clear, still costly. Like we shouldn't just randomly remove items that are not malicious that people want to sell because of the bad user experience. But I would say, like, I'm just thinking about how much costlier is the first thing. There are also risks, like we can be selling something for a long time, but regulator might not come, so we don't actually incur um, any costs. But if they come, there will probably be a huge fine that is like 100 times more costly than whatever we use if we use like one client from not being able to sell something non-malicious. Okay, so basically, I'm thinking whether we should be um, focusing just on those false negatives. Probably not. We will still control that false positives are not that bad, but false negatives are the most important. Okay,
That's definitely true. Yeah, that's correct.
yeah. So then, like, how I would also go about this situation, I would also go to like product people or maybe some other
Hmm.
legal team and discuss with them what are the actual costs for us, just to be clear about like how should I um, calibrate those two errors against each other, because it shouldn't be like 100% of some one and like 0% of the other. It should be maybe 95 to 5, maybe something else, just to be clear that we are like on the right trajectory in solving this problem. Not overdoing this, because the obviously like to take it to the extreme, absurd way to do solve this problem is to not sell anything. Then you have solved the problem, right?
Yeah.
Yeah. Okay, so that's just like in business terms, we can really calculate what are the risks for us in money terms, right? And then, yeah, there are also many countries, etc., etc. So I would probably just use some simpler heuristics here.
Okay, like what?
Uh, Basically, I want to, like, I will measure the risk that if we are selling some product and it gets found, like, what will be the fine? And I maybe like I will just talk to people. I will average the fines. I want to feel the money, right? Like because there are
Okay.
probably huge money in this problem, but is it like millions? Is it tens of millions? Is it just like hundreds of thousands? Because all of those options will lead to different approaches to the problem and how big a team can we build to support this problem, etc.
That's true. I think here comes another important detail that you touched upon. So let's dig into this, into the evaluation, like how would we understand if the solution is even good, right? Um, so there are multiple issues, and some of them can be more severe.
Hmm.
Yeah, so say you cannot sell drugs. It's really not. Oh yeah, for example, prescription drugs. Some prescription
Hmm.
drugs are like super dangerous and also super um, mm, both dangerous and kind of you have a much higher escalation risk for them than some very
Hmm.
obscure problem that's still dangerous but people barely sell it, and so it's not so kind of it is bad, but it's not as risky, you would say.
Hmm.
So for now, let's say that we have nothing in place
Hmm.
to handle the risks, and we have multiple issues. Say we have three issues.
Okay.
So we need a system that also, yeah, as you said, can take into account the fact that some issues are more costly than others when, or rather, not the system should, but we, when we prioritize our work, we can take
Yeah,
that
yeah.
into account.
I
Yeah.
see. Yeah, I skimmed this for not a good reason, actually. Yeah, because probably the way to calculate this is not to average things, is like selling drugs is much worse than selling like maybe this like one baby product somewhere from some non-malicious person, right? So then actually what's interesting is how can we scale our system to more policies, right? Because
Yeah.
creating just one model, like if it's a power load distribution, that like
The distribution of
99%,
what?
the distribution of cost for different things, right? So
Yeah.
basically,
Yeah.
then the most important thing should probably be like taken the first, and only you should focus only on that, because the next thing is like 10 times or whatever less important. But if it's not a power law distribution, if it's more like so you should just address this one thing first and then scale to other problems and see how you do that. But if the distribution of costs is more like less extreme, let's say, then you should be focusing on all of those problems or many of those problems at once. And then probably depending on how costly all of this is to the business, either you have a big team, like maybe 5-10 people who are all working on different aspects, different policies, and maybe like one person per policy, per important policy. Or if it's like, and then you can scale by people. That's what I'm trying to say. So essentially, each problem can be a separate machine learning model, even because like running 1 or 10 models, as long as they are, it will be pretty much the same in terms of costs. The most costs will be, as long as we have 10,000 items per day, even in like 1,000,000 items per day, it will still be more costly to hire people. To hire more people. So basically, this will be our bottleneck and our constraint, not the amount of compute we are spending on this, as long as we are not using something crazy like analyzing videos with LLMs or something. Okay, but I'm getting a little bit sidetracked. Let's just say that we will be trying to cover many problems, not just one, and we will consider that there will be like several important things, and we will be let's see, like if we don't have anything at all right now, we will still probably start with some simple solution that can be applied to all of those things. But yeah, I'm not.
But
I'm trying to think.
you've touched on an important thing, like on the fact that we need to scale to multiple issues. That is very important, and it's true. Yeah. Well, but let's say that for now we were asked to focus only on these three issues. So you have to keep in mind that the system should be scalable, but you don't have to build like the spaceship that will scale to an infinite number of policies. But yeah, it's a good point. Like if we are able to scale with just people, that's actually good, because in the limit, I would say you can expect hundreds of policies, but like that's like later. So yeah, you can expect up to hundreds of policies in total ever. Yeah.
Okay. So
And there was another thing. So we briefly started discussing metrics.
yeah, I
So
will focus more on this.
yeah, so let's think about them a little more, I think. So now that you have, say, three issues, um, and it was mentioned that we should find the relative cost of false negatives and false positives. What is something you would propose for judging the final kind of solution for one issue? How would you evaluate how good it's doing?
So like the basic thing would be to look at recall of all of those,
All
right?
right.
But those don't consider like the precision. So we can get false positives, more false positives than is useful for us. So if we have relative costs of those things, we can just weight those two problems, those two errors. Basically, we can multiply by the cost of each, and then this will be
Yeah,
the
but
final.
the problem with recall is that so you have a marketplace. It has like millions of products. You do not
Yeah,
get a label for each, right? Do you know if it's prohibited or not? Because if you did
we
it, you would just
haven't
remove all the
discussed.
prohibited things. Yeah.
Yeah, we haven't discussed like what is, how do we get the truth, the ground truth data, right? And like if we have some label data, I plan to talk about this. But basically,
All right.
we will
All right.
have some label data, and we will probably have some like external like moderators or something. Like we will need some help. This is just a
All right.
uh, and on this label data, we will basically have three data sets, one per each policy. I think. And then for each of those data sets, we will probably have, for each of those policies, we will have different combination of like precision and recall costs. So I will just like on this label data set, focus on how well are we doing with this like recall and precision, and we can
All right.
weight those and train a separate model for each, but we will discuss it a little
Do
more
you know
down
maybe
the line.
do you know maybe a metric that is weighted average of recall and precision that could be
Yes,
used?
there is a harmonic mean between those two, which is
Yeah,
called
yeah,
F1. But F1 considers those to be equivalent to each other in terms
yeah.
of costs.
But can you
There
extend
is,
it to? Mhm.
oh, okay, so you mean actually there might be some other metrics that I already forgot about, like classification that
But no, actually, you're on spot. It's just F1 is a specific instance of a more general metric you could apply here,
Okay,
right?
well, I guess this
Yeah,
harmonic mean can be weighted harmonic mean,
yeah, yeah,
and then yeah, then we can like average
exactly.
those in different ways. So let's measure those, average those harmonically, and then it will be probably have some nice behavior to it. Okay, but let
All
me
right.
actually
That makes sense.
circle back to what we are actually trying to achieve here. So we have three things. We will do classification, obviously, for those things. We formulate this in terms of business as we want to uh, calibrate and balance the costs, and like obviously we will focus more on the cost of false negative, so not finding the right product to remove, and then we will build a classification system that on any create or update of an item redoes the prediction. And then we will have prediction score. On offline metrics, we will use like this harmonic mean between recall and precision. Among online metrics, it's a little harder because we don't have, I don't see at least some direct signal, but probably we will have some reports. Like if you look through, let's say, I don't know, some e-commerce site and you see them selling drugs, you can just report that you are seeing some product that shouldn't be there. And I think this might work as a good online metric, like seeing how many of those
Yeah,
issues
let's
people are
talk
finding.
about online metrics. So, uh, imagine that we do have a button next to each product that allows a person
Mhm.
to report it. Uh, is that enough? And like even with this button, what would you calculate? How would you
Yeah,
understand? Yeah.
that's complicated because
Yes.
we have many policies. Many people might
Yeah.
not even like people might not even know that this baby breastfeeding thing is probably shouldn't be sold. So for some of the policies, we might not get any clicks on this like report button. But if for something
Or
like
they can
drugs,
be for unrelated reasons. Like
yes,
people clicked
or they
because,
can be for unrelated
copyright
reasons. For
infringement or
drugs, we
something.
can have many of those things. So
Yeah.
how should we use this? Like in general, I would expect the distribution of items would be similar from day to day. There will be probably some changes, but not drastic changes. So we will have some baselines for the number of reports that we are getting, and if there is a new malicious actor that is trying to get many items to our system, then probably we will see some change in the reporting of in some categories. So basically, we can look at reports by category or something, and just even this metric would probably be somewhat informative, but not perfect, definitely.
It has one big flaw is that the things we're looking for are like the most prohibited of the prohibited, and that means there are few of them. I mean, if our website was full of them, we would be out of business already. So if there are few of them, there are few regulatory reports, there are few like even maybe fewer or comparable few anyway um, reports by just the regular users of the website. And so overall, you have a very sparse signal because
Yep.
even just one such product being sold can get you a lawsuit. Uh, but yeah, it's very hard to know if it's there.
I see what you're
Can we,
saying.
yeah, yeah, can
So,
we measure something?
mm, so okay, let's imagine that we have those products, and at any point of time, we know that we have those. But the better our system works, the more products we are removing. So let's say we have a stable amount of products, of malicious products, even uniformly distributed across policies, added each day, which is
Right.
a strong assumption, to be clear, right? Like finding and removing those, how many do we find and remove?
We can definitely calculate how many we remove, right? But the
Yep.
hardest is to know how many we did not remove but should have, which is the recall. But it's like the
Uh,
impossible problem in all such problems to calculate the recall. But
yep.
maybe we can get something close, something similar
Some proxy
correlated
for
with it.
this.
Yeah, yeah.
Um, hmm.
Well,
Give me a
let's write
hint.
down at least that we will. Yeah, yeah. So for the online metrics, let's at least write down that we can agree, we should be tracking how much we remove, right? It
Mhm.
is in itself not a bad proxy metric. I mean, usually if we remove more, then we're finding more, and that's good. There are issues with this metric, of course, because, for example, if just there appears more bad stuff on the website, now we're removing more, but not because we improved the model.
Mhm.
Yeah, and we can always cheat this metric, of course, by removing everything. Okay, what else can we do? One thing we can consider is that what happens when we make a mistake, which is a false positive.
Yeah. Mm, so probably there will be some button where you can say that I didn't do anything wrong. So there will be
Yeah, exactly.
a customer like so basically I
This
don't
is
know how to
an
call this,
appeal
but
process.
appeal, yep,
Yeah.
appeal. The number of appeals is a reasonable metric, I think. Here, like we can use as denominator the number of products that we have removed, and number of appeals per the number of products that we have removed should be a good metric here.
Yeah, so it's more like an appeal ratio, right?
Hmm. Yeah,
Not
appeal
appeal.
ratio.
So this is the ratio of appeals to the number
To the
of.
number of
Right.
products that we have removed. Yep.
There's an additional problem that if we have multiple issues, we kind of want this metric per issue, but we only have this metric per everything.
So
So we
you
can
mean that we can have like several policies can trigger on the same product?
no, no,
Do you
no.
mean that? Oh, you
Okay,
mean
so
that there can be several reasons for removing the product. We are focusing on like maliciousness of the product, but maybe there is also like something else that some other teams are
it's
building.
also true, but I think for now we can leave it aside. All
Ignore
right,
that.
let's move on. This is a good metric. So we have the appeals. This kind of a measure of how many false positives we get, right? So it's kind of precision. And we have how many products we remove. What is the reports one that you wrote down?
The report says like how many uh, reports are generated per the number of products that we are selling at this moment of time on our platform or something.
By reports, you mean the
Yep,
user reports. Yeah.
user reports.
One
Yep.
last thing I would add to this is something related to the regulators. I mean, they um, communicate rarely. That's a
Mm-hmm.
problem. Not like super quantifiable, but you can calculate something, right? Like this year, they reported 2 times less than previous year.
I
Probably that's
think
good.
I wouldn't call this online metric. I definitely agree that
Yeah,
this is
yeah, yeah.
something worth
More like a
measuring, but
business
it will
metric.
be something like a business metric for the whole
Yeah,
product that product people will be focusing on, like how
exactly.
even not even just like the number of times they reached out to us, but all the total amount of fine that
What
we
you
had
wanted
to
to say
pay.
is way out of my pay grade. right?
Yeah. So overall
That's
regulator.
actually pretty solid. We could get more creative with that, but I think we can return to
Yeah,
this later if it's interesting. Yeah,
sounds good.
yeah,
Let's move on.
let's move
We
on.
wanted to discuss the labeling of the data, right? So um, some of the one of the things is like first we will probably already have some data because there were products like maybe regulators came to us and said like you shouldn't be selling this and we have found all of those products. So
All right.
there I will be assuming that there is some label data, but then what to do next, right? I know that there is a good tool, good method here. We have embeddings. Let's just say we have embeddings. We will discuss later on how and why we want and make how we can do that. But let's say we have embeddings for the products, and then we have embeddings for all of those malicious products in our label data. Then we can retrieve products that are like use approximate nearest neighbors to retrieve more of those and use our moderation team to well, because those will probably be very similar and they will be on this border hopefully like either they will be bad products all of those and then we just are just growing our data set and maybe also removing those killing two birds with one stone but also they will probably be at one point on the brink between malicious and a good product and we will need people to decide that and we will have some good examples that will train the model on this like border between those two things. So
All right.
that's how we
Let
can.
me yeah,
Yep.
let me interject a bit here. It's correct that we have embeddings, and it's a very solid approach for the search. So yeah, we can assume we have like search or recommendations. So for sure we have embeddings of some kind. Uh, they might not be the best embeddings for this task though. So, but for the product safety, I think at least it's a very solid baseline. Yeah. So you can start. Yeah, I just wanted to confirm. So first of all, yes, we do have some data. So we do have some or previously reported items, and we do have some embeddings. And getting some moderators is also, I think, a solid idea, because
Yep.
yeah, uh, I guess the addition I have to make here is that actually, if you just do a keyword search over a huge collection, a lot of the items will need to be additionally checked by people or something, because the
What do
policies
you
they
mean by
can
additionally
get
check?
very.
Yeah,
I mean,
policies
if you
can.
just threshold by very similar, you would get a lot of false positives. That's what I'm saying.
This is still fine. Like the
That's
problem that
true.
I'm seeing, the problem that we will definitely have that you already mentioned is that there are very few such products because each one can
Yeah.
be like devastating for the platform. So by default, we shouldn't expect a big training set, and we need like the better training set, the better the model we have, right? So it will probably be worth it. I would like guesstimate that we can increase the training like the malicious example size by like 4x maybe 10x by just doing this it depends on like but
Oh, so
basically
oh
it's
yeah, yeah, yeah. Sorry, I thought it was your idea for the for deploying a kind of basal
no no
solution,
no
but you proposed
I'm
to
just
just gather the
gathering the
data.
data
Yeah,
here.
yeah,
Yeah.
100% correct.
Yep, sorry I wasn't clear. Yep,
Yeah, yeah,
I'm
yeah. No,
just
sorry.
gathering the data. So that's the first step. Basically, we have some label data. We increase the data set by retrieving like closest data and using people to label those. And now we have reasonable data set, let's say, that we can use to train our models. Obviously, we can always randomly sample good items from the our base to have positive examples. But even as it is, we will have very imbalanced data. So we will have to be careful there, like how many do we sample, how do we sample this, but let's keep it later if we want to discuss this. So that's how I gather the data. Now let's discuss what can be the actual features quickly because like it's pretty much obvious. So the labels are clear, either it's malicious or not. I don't think there is some middle ground in between those. There is also probably we will be labeling by policy. because I don't know if it can be possible that one item will be bad for several policies at the same time, and I don't think it's
Let's say that
important.
no. I think it's a very rare
Let's
case, even if it
but
happens. Yeah, you
yeah,
only have to find one policy that it violates to remove it, so it
yeah.
doesn't really matter.
Okay, so I will be discussing the entities. So the entities that are participating in this whole process. So there will be a customer account, right? The customer who is creating all of those things. Then there will be the item itself. Then just to check, like if there is some discussions or likes or shares or anything, and people who are liking or sharing.
Let's say that maybe you have something, but it's not clean enough, not reliable, way too much work for now.
I, I will still have it here like customer
All
item,
right. Yeah, yeah, yeah.
and then for item there will be general things, but there will be also contextual things. So I will just leave it as context as a separate entity, but this is kind of item part. I will explain myself shortly. So customer. So let's think about the customer. So there will be some demo geo, like, and by geo maybe let me add language separately, like system they're using. Maybe they're using several systems, but whatever. We can also embed this. Um, but essentially, those are the main things that we know about the customer. Then there will be a history of this customer. So I will say history. And in history, there will be a lot of stuff, but the most important part will be history of the items, right? And like history of reports. This
By
will be
customer,
some
you mean the seller, right? The one who is selling
seller.
the
Yeah,
item.
yeah, sorry,
Yeah, correct.
seller. I maybe I mentioned that I don't want to focus on this information right now, but I will still use seller item and then buyer. How to write buyer item.
Yeah.
So these are also some things that we can get. Reports. Okay, so what else? Let's focus on item. So for item, we will probably have text, image. We can say that there is video and audio. I think if we
Sometimes,
are,
yeah.
yeah, it might be, but
But we can
doesn't change
assume
things much.
only very few items have interesting video.
Yeah,
So I don't think that like first iterations we need that really. But
yeah,
let's
we'll
see what
mention
we do.
this. It's I probably won't be gathering features from this the first iteration, definitely. So image, and then for context, right? It's uh, uh, like when, how, published, like time of day, all this kind of stuff, and then updated or created, this like flag here, because maybe there is some different behaviors in, like, as we discussed previously, you update items to make them malicious or something. So for the item, they're like seller item, seller item. Actually, I don't know, but for buyer item, like likes or shares or likes, comments, maybe that we usually have something like this. For comments, we also can have like the analysis, sentiment, maybe even analysis of this. But
Yeah,
basically,
yeah, it's possible.
we are gathering all this information to entity
You
level.
also have clicks, views, and all that kind of stuff.
Yeah, views. That's true. Actually, now that I think of it, maybe we should also consider number of views. I'm looking at this from the perspective like if there is a bad item that is not seen by anyone, is less reputation risk than if there is an item that is viewed by a lot of people, right? So maybe we
That's a
should,
very important point. Yeah.
yeah.
It's one of the tricks you kind of can use for sampling. So you could first of all check things that are like already being sold, and that way, or being viewed a lot. That way you cut down the volume you need to check by a huge ton.
Hmm.
Good point.
Yep. Okay, so I think this mostly sums it up. I probably have forgotten something if I did. Just give me a hint. But let's talk about how we can encode some of those features quickly, right? So
Yeah, let's dive into the solution.
into this, by the solution, you mean to the modeling part, or like how do we encode with this?
Isn't it the same?
Yeah, well, when I say encoding, like let's say, just to give you an example system, right? I mentioned that we can embed this. And
Yeah.
it's worth discussing a little about like how can we embed such things, like maybe for demographics we can also like have sex of the seller, right? Something like this. We can also do embedding for this. It can be just a Boolean variable, and probably at the beginning it will be, because I haven't mentioned which model I will be using. Probably there
Yeah.
will be several iterations. So when we are doing, I will start with something relatively simple that has interrelation, can analyze interrelation between features. We don't need much interpretability here. At least I don't see it. So I would probably go with something like random forest or gradient boosting for the first iteration. And then for the first iteration, we will probably use like sex as a binary variable, and the same thing as like updated or created here. Like all of those things will be
Yeah,
binary
let's
variables.
let's discuss in two modes. Like, what would be the first thing you would deploy, and how would you would proceed after that?
Okay. So the first thing is that we have like where should we get the most information? Yeah, and it's like a lot of information we'll get from images and text of the items, right? And the best way to encode those is to use embeddings. I don't think that like, yeah, using bag of words, something simpler, might work for text. Like if we have a big enough data set, because there will be a lot of possible, like there will be a lot of features. We don't want to get in the situation where we have like a million features and 10,000 examples that we are training on. But why am I discussing all this? Because the best way to represent image is obviously in encoding, embedding, and embeddings are working better with neural networks than with some like gradient boosting. We can still use those, but it will be less efficient. And I'm not sure if I want to go directly for the for the neural network solution. I'm not sure. Okay, let me think about this a little. Like, I think that training a gradient boosting model, we will probably need something deployed ASAP. So I think gradient boosting will take like, let's say 1 month to train and deploy and prepare all the features, like simpler versions of the features. But for the actual neural network, it might take longer, and it's like high risk, high reward. I would still start with the gradient boosting, and I would still try to use
Yeah.
images as vectors and see how it works.
Okay. So images as vectors, but where do you get the vectors?
Yeah, I didn't discuss this.
Yeah.
We can use as the first approximation, right? We will use some clip model or whatever,
Totally
and
reasonable. Yeah. Yeah.
yep. The same thing like for texts, we will probably use BERT that just provides an embedding for the whole text. And the same thing, like we can, for example, do BERT over comments and then gather all of those, like average those or whatever. Then for all of these variables, like where we have, like for example, history of the items, right? Reports can be a count, but history of the items, we can represent item. Maybe we can even just take images or something like the main image, the text embedding, and average this over history
Yeah.
as
Yeah.
a first approximation. So this stuff, use this vector and concatenate the vectors. This is also problematic because, for example, vectors for images will be much bigger than, we can obviously tweak this, but we will have like 700 variables for the image and one variable for, let's say, updated or created. It will still work, but like neural networks with attention will be a better solution here. That's what I'm trying to say. So, but we will still start with like gradient boosting decision trees, and then move on to neural networks. And once we move on to neural networks, we can, instead of all of this, we can actually start doing embeddings, maybe like even item level embedding. Uh, Basically, we will have an embedding layer, and for each item, we will have like, we will be training neural network and we use backpropagation to learn those vectors, maybe learn the vectors even for things like system, other stuff. Maybe we will also unfreeze like the layers of image
Yeah, yeah.
model so that they are like learned closer to what we actually mean. But I think this might be an overkill, just to highlight, because we will not have enough data to do this well, I think.
Also
Like,
true. Yeah.
so if we have unlimited amount of data in this theoretical scenario, then yes, we will do all this. But otherwise, we'll do something simpler, like as long as it improves the model. So, yep. Then
So
we
after you
haven't.
have deployed, yeah, sorry to interrupt you.
Uh-huh.
So after you have deployed this gradient boosting tree, so it works kind of like a classifier for a specific policy, if I understand correctly, right? So how do you actually use it? So you have all of these
That I
items.
haven't discussed yet,
Yeah.
actually. Sorry, it looks like I'm interrupting now, but um, essentially, there will be many policies, and I would start by training, like since we have just three, I would start by training three separate models, three separate gradient boostings for these three policies. Because for gradient boosting, it's also like multi-label classification. Yeah, three models is simpler. But once we go on to the neural network, obviously, maybe not so obviously, but there will be some information overlap between different kinds of policies. There is like a general sense of maliciousness that you can learn. So it makes sense. And there is more data if you consider all the data at once. So you can have multi-head neural network
Yeah.
where each head is predicting a separate policy. And then
True.
it's actually also good in terms of extending to new policies. It's not an easy problem because let's say you get fourth policy, you extend your neural network to this fourth policies, and the first three policies become worse. But you can now like you now have four, and the first three become worse. What do you do then? How do you
Yeah, yeah,
approach
yeah.
this? Hopefully, this is not
That's a
something
good
that
long-term
happens.
vision. Yeah, to have a head for each policy. It's a good long-term vision.
Yeah, but essentially that's it, right? Like, so first we will be training a separate model per each problem. Then we will transition to a neural network that will have just like all predictions, produce all predictions at once. But then the next step is like how to actually deploy this, right? I think we don't have strict latency constraints. Like if it takes 1 second, is not much longer than if it takes 100 milliseconds. So I would just create a queue where we put all the update or create events, and then we retrieve, like we just put like item ID or something. Probably we have this. So we put this in this queue, and then we retrieve it from the queue, make the prediction, put it back somewhere, and then this prediction is just a score per policy, and then we have some business logic on top of these predictions that decides what to do with this particular item based on these scores. And we probably just also stored these scores in the database for like review later or something. And
Okay, so do you propose to score every item for every policy, right?
yes, like at least in the world
Yeah.
that we live in right now, we have three
Yeah, yeah, what 10,000
policies. So we just
items
run
for the
three
policies, it's
models.
feasible. What if, how would it change this process if we grow and we have like a lot of items? Like, I don't know, we have a million
Like,
a
to be
day,
honest, yeah,
millions a
I
day.
don't think, I think this is purely theoretical, to be honest with you.
Okay.
I think we will never get to a point where this stops making sense. because
Hmm.
in the real world, even if we have millions of items added each day, like we can have billions of items. There is just not enough
Hmm.
people in the world, like unless there will be, unless we are.
It's not true because there is a lot of automation.
Yes, that's
Like one
yeah. I
seller
started
can
thinking
publish
about.
like a million items a day easily.
Okay, makes sense. Yeah. So let's say that we are constrained by this, and I was wrong. Maybe we will
I
face
imagine
some
management
situation.
asks, yeah, you, but what if? What if we get a lot of items? Can we check
Uh,
everything?
yeah, let's say we are integrating with five, like Walmart and Target
Yeah,
and
yeah.
other companies, and they now want to sell on our site. So what do we do in this scenario? I think one thing that really easily comes to mind is, let's say, okay, we don't have embeddings for those, but we can create a proxy for the embedding, which is like maybe embedding the images, embedding the text, concatenating those, stuff like this, right? It's still like it's relatively cheap, and we don't need, we will probably still need those down the line. So I will probably go to product team and to other engineers and discuss like what is the most general embedding that we have. Let's just create some system that creates those most general embeddings, so that the new item then it is added to the platform. Like let's assume now that it has this embedding. So if this item has this embedding, then we can also find the like neighborhood of malicious items. So I would expect that by default, the like if you are not close in this multidimensional um, space to malicious items, there will be many more, like much more of this space will be not close to these malicious items. So if our items are uniformly distributed, which is still a strong assumption, but let's assume, then we will be able to filter out like 99% of items easily by just seeing if they are like relatively far from malicious items in this embedding space. So I think we can even tweak the threshold in such way that we have like maybe we will be removing 70% of items, like 80% of items, but with 100% correctness. So we will never miss anything that is malicious in those. Um, this might still be like maybe we will need to maybe just like Euclidean distance will not be enough, and we will have to like be more clever about this in some ways. But that's a reasonable way to solve this problem. So we are filtering out a lot of items, and maybe we also can use the reputation of sellers, because like if seller has sold like 100 of items on our platform and none of
True,
those were
true.
malicious, we will probably we shouldn't like by default we shouldn't uh, target this the new product sold by this seller. This is complicated because uh, in this way we can miss some items. Like maybe someone has bought some other account like from someone else. It's not. Uh, so this would work for bursts of new items being added. Maybe we can even say that okay, Target doesn't have any malicious items. We trust them, or maybe we can have a contract with them that says if you're adding like all the legal risks are on you or something like that, then this works, right? We don't even need to run
Yeah,
our
yeah, yeah.
model.
Yeah, but
Maybe we
when
have
you get
other
into
reasons
the
for burst.
territory of those kind of heuristic approaches, yeah, it
Yeah.
starts getting really complicated because then people start abusing it, and then you have to add all those edge cases to somehow. But let's say it, we will handle it later. That's a
Yeah.
problem for tomorrow.
Okay, so
Okay,
just a
great.
few things left, right? Like I already mentioned how I deploy this. I think another interesting aspect is like we already mentioned that we will be transitioning from gradient boosting to neural networks. How do we ensure that this new model is actually better? Or like, let's say we uh, continuously trained our neural network on new data. So how do we ensure that it's working better than the previous one? I think in this scenario, shadow deployment in our like 10,000 items per day, shadow deployment is a good scenario because we will see like how our metrics correspond from one model to another. Maybe we will actually figure out that we'll need to ensemble some models. Maybe neural network should give our predictions, and gradient boosting decision trees should make predictions, and then we have business logic that combines those two. But in general, like shadow deployment, where we have all of those predictions are duplicated for some time until we decide that we want to transition to the new model. Maybe this is the best approach because it will be relatively cheap to run all of those at this scale. And we know that missing one item, like approving one item, can be very costly. So probably like even running 10 different models and assembling those is hard from the engineering perspective. It's messy. We shouldn't do that ideally. But if it helps us save one more like malicious item not being added to the platform, maybe it's worth it. That's what I'm trying
Yeah,
to
but
say.
you start getting more false positives too. It's
Yes,
probably
yes. Basically, you
sometimes
can
you
do
have those
ensembling
ensemble
on
models.
top of
They
all of this.
yeah. Ensemble models, they can be correlated wrong, and then you have false positives too. It's annoying
Yeah,
in a
that's
way, but it's a solid thing to try. Yeah, for sure. Is there? Yeah, this is a like contained complete solution from my point of view. Is there anything like else you would like to add to it, or otherwise, I think we can wrap it up.
I don't think like we can try some deep dives, but we did a few already. I don't have anything else to add. I know that I should say A/B testing or something because I was
No, not
actually
in this case.
the people like literally I didn't say A/B testing, and that was one of the reasons I got no higher in one of my
Oh my God.
interviews.
Well,
Because
lucky for
maybe I
you,
don't
first of
know.
all. I'm not hiring you either way, so you had no chance to pass this interview. I'm not making these decisions. Also, yeah, A/B testing would be the wrong option here anyway. I mean, you cannot really A/B test. Like, we let this cohort of people sell cocaine, and for these people, we do not allow it. And then we check the metrics. Yeah, that would be weird. Yeah.
Yep.
Well, thank you. I think it was very solid. Would you like to hear feedback on
Yes,
my part?
sure. I think
Yeah,
I hope if anyone watches us still, they might also be glad to
yeah,
hear
they
the
could have.
feedback.
Yeah, I think like really it was solid, and for me, wow, my very complex rig for streaming is collapsing. Okay, seems stable. Um, it was solid, and the main thing for me is that you had, I think, a good structure and um, mentioned all or most of the important points here. Like I think the most important point overall is the different cost of false positives versus false negatives. At least that's what I am looking for when considering problems as such. It's like the entry point. If the person does not mention this at all, uh, it shows like they're unfamiliar with the whole huge class of machine learning problems where this is important. So this is super good. You mentioned scaling to multiple policies. This one is more actually more specific and more surprising in the sense that it's very shows the engineering manager in you, and that's good. Yeah, because this one is what most I think machine learning engineers, like I see people, they would miss the fact that the difficulty of this problem, it's not that you have to fit a model for like detecting a specific kind of product. The difficulty is that today you have three policies and tomorrow you have a 10, and five become more important than before and three are gone. So it's a constantly changing field, and the real difficulty is building, like, so you have a huge company with all of that constantly changing, and you need a system to support it without like having to manually solve each problem as it occurs, because you will not have people for that or time for that. It's impossible. Yeah, let me go through my notes. It's also really cool that you mentioned the proactive deleting, and I think it would actually, like for an interview, also make a good problem to make a system for the proactive checking if something should be posted. It is also a very real problem, and I think slightly different. Also good that you mentioned also editing, so you kind of found most or all of those gotchas that appear in this problem.
You said there are no gotchas.
Now, gotchas from me, like that I expect, but there are objective gotchas in the problem where
Yeah.
you start working on it and your whole team finds there was a gotcha. Yeah, but not in the way I posed the task. That was my intention. Yeah, I think good discussion on embeddings. Here I would have enjoyed to hear more like on the specifics, but you said the main, I think, things like first you can always take a clip and a bird and start with that. Yeah, that's for sure. I think there's a big area of improving in this task on developing better embeddings, evaluating embeddings, and so on. And then it gets into this in this kind of ranking problem territory. So this is probably the only thing that was kind of missing for me is formulating this as a two-stage problem where first you have search and then you have decision making. So but given the scale I mentioned, like with 10,000, it is really feasible to just do the decision making on everything part. Realistically, on a huge marketplace, you cannot, for different reasons, check like all the stuff that's getting posted and edited. And then you kind of have this first step, which could be keyword search, could be ideally embeddings and stuff. And then you have the step where, so at this step, you're kind of maximizing recall and you're trying to get rid of the 99.9% of irrelevant items. Because you always, for a problem like this, for something as super rare but very important, most of the stuff is not relevant like at all. So maybe you have some section of your website that only sells car parts, and you know there are mostly car parts, and most likely somebody is not posting, I don't know, baby feeding devices there, most likely. But so you have a bunch of car parts that you just need to get rid of before you apply any costly models and so on. But with 10,000, yeah, it's totally feasible what you proposed. Still, I think the kind of solution could be improved by discussing. So with the filtering part, the embeddings, and how would you evaluate the quality of this filtering? Because you can evaluate the quality of the final solution, but in this case, you can also evaluate the quality of the embeddings or any kind of filtering by mean average precision at R or whatever ranking metrics that are like, did you get a good top 100 results from this query or not? That kind of stuff. But again, I wouldn't say it's any kind of mistake on your part. No, we're just saying that it could be a thing that could be added here for like more flex. And yeah, I think a good discussion on the modeling part. I agree with going with something like a boosting as the first iteration. Could be the last iteration, and I think it was a good vision with having like a common backbone that produces the features for items, and then having a head per policy. I think that's good. Also, if you wanted to be fancy, you could also have a LoRa adapter per policy, which is also kind of almost as if you fine-tune a network for each policy, but cheaper and usually will work just about the same, I guess. Yeah, there's also the aspect that what could be mentioned is more zero-shot approaches and big backbones. So in those areas, in some policies, you can have very few examples where training can actually not even work, just not enough. In that case, you might be just better off asking some zero-shot model, like directly applying clip as a zero-shot text predictor or something, or just asking an LLM, like, is this thing, does this match this policy or something? It can work real well, especially given that mm, it's faster to deploy. So you could
Mm-hmm.
also maybe extend the idea with the embeddings just one step further and say we can also use the embeddings for zero-shot classification, so that when a new policy is added, we can quickly make a baseline kind of solution. Yeah,
Mm-hmm.
and another thing that was missing for me is that mm, maybe it was worth mentioning that uh, after you deploy the model and get the results from the model, you can actually double check that stuff by people. So if the model works as a kind of thing that
Mm-hmm.
narrows down the sample to a manageable like list of candidates, actually given how important it can be, you could use people, since we also mentioned using people for the labeling. You could use the same people. Um, yeah, I think it would be very practical, but that was also covered. You said so we use a QA, we assign scores to the items, and then we apply business logic. So it kind of, yeah, we can
Mm-hmm.
say, I would say this an even better approach, because with this approach, if you have the results of the model, you can decide later. Do you want to just outright report them or like remove them instantly? Do you want to the business logic to be like sending to some people? Yeah, that works. We can assume some other people will take care of it. So,
Mm-hmm.
so again, good job. Yeah. What else? Mm, yeah, and the point on shadow deployment also was right on spot. Mm, overall, I think, mm, like in this case, it's related to my work, so I had an idea of what I expect, but even even then, so it always biases you kind of, because you're like, I did it differently and so on. But I didn't feel much of that, so I think what you proposed would be totally realistic from my experience. Probably like real system for a website that will remain unknown. It has like a million more different caveats and so on, but I think that's a very good job. Like, if I was interviewing you, I would be like, yeah, this guy will figure out what needs to be done.
Okay. Thank you, Boris. I hear this is a higher decision. Uh,
Yes, it is.
yeah,
It would be
thanks.
for me.
Uh, could you please elaborate on one thing? Like you mentioned
Yeah.
that discussion on embeddings was lacking. So how would you approach this? Like what else would you tell on top of what I was saying?
Yeah, I was thinking about mm, getting a little bit into the specifics, like what kind of model would you use. Um, like, okay, there's Clip, but Clip was 2021. There are a bunch of Clip-like models and so on. And BERT, yeah, I mean, you could um, it would help to say something like, okay, there's modern BERT, it's multilingual, it's very good embeddings. Also, there's this new Siglip by Google, Siglip 2, which is very good. And like we, so in these items, we usually have text and images that are related. So the
Hmm.
title is essentially a caption for the images, you could say.
Hmm.
So you could say that something like a clip is like a perfect thing to represent the idea of this product. If you take um, if you take the same model and apply it to both
Hmm.
the image and the text, say a clip, and use the text encoder of this clip to the text, and the image encoder. Yeah, so something like this.
Hmm.
Oh, also for additional hype, it could be mentioned that you could use LLMs in that problem a lot, like at the point of labeling, at the point of just using them as a zero-shot model. Just here's the
Hmm.
description of the policy. Tell me, is it matching or not? Um, I have even seen LLMs getting used for matching, and I was like, but you could just use KNN or something, but you cannot argue with the results. It works in the sense that you could, like I've seen people pass a list of titles and similar stuff. Well, not anyway. So you could basically use an LLM for text search, and it actually makes sense in the sense that you can set it up and learning in a few minutes compared to even doing simple machine learning, even extracting embeddings and stuff. I think here is one of the problems where it's kind of a ripe playground for that.
Okay.
Oh,
Yep.
and one more thing I forgot. Speaking of the overall structure, I think it would benefit to speak. So you have the regulators that come and check the website, right? And a simple thing that could be done, like before any kind of machine learning data collection or anything, you could say, okay, we get people that use the same policies and they check the websites, say, every day,
Yeah.
and make sure. Yeah. This kind of, you can assume it already exists, but still worth mentioning because, yeah, it would be the actual business go-to solution first.
Yep, that's true. Thanks. Well, Boris, thank you so
All right.
much for spending this time with me. It was fun doing this. I'm happy I did well enough and didn't really embarrass myself in front of the whole internet. However, try.
Next time, there's always tomorrow.
Yeah, there is always tomorrow. So, yep, I guess that's it. Let me stop our. I
Right,
think
bye
I guess I
everyone.
should find a new button somewhere. Okay, let's hope stop button works.
How
See you
many machine
all.
learning engineers it takes to stop
To
this
stop
thing.
streaming.